words, that implies I'm the leader. I'm not the captain, I just gave them something they can believe in. I hold the lamp in the darkness, but they're the light that I needed to see the road that we walk in between the angels and demons. And my fans have my back. Hate us if your feelings don't like facts. And my fans will fight back. Beat you with the keyboard you've been using to write back. I guess we need each other like both sides of the battery. We the army, we the homies, we the gang, we the cavalry. We're brothers and sisters, we hold it down like we gravity. Can't nobody break the bond that made us all family.
Me and my fans, we don't care what anybody say. Middle fingers to whoever in the way, man. Me and my fans, we gon' be together to the grave. It's the game till forever and the day, man. Me and my fans, we don't even trip in the hate. We the I don't give a fuck in our veins, man. Me and my fans,
We the hangover gang. Gang, 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 gang.
Oklahoma weather can dish out some of the worst punishment in the world. Hi everyone, I'm meteorologist Tuttle. But now you can fight back by installing Class 4 impact-resistant shingles from Ferguson Roof Systems. These shingles can withstand large hail, heavy rain, and hurricane-force winds, all while keeping your home safe and dry. And the best part? This upgrade is completely free for many homeowners. So call today to start reaping the benefits these Class 4 shingles bring, including a discount on home insurance. Only at FergusonRoofSystems.com.
Hey everyone, Meteorologist Tuttle with you. It is Saturday night, it's about 10 o'clock. It is time to talk about the weather for late tomorrow on into next week. So we do have a potential for some severe weather, so we got to detail that for you. So thanks for joining me. Kick back, sit back, grab a cold beverage, glass of wine, whatever it may be, and hang with me. And we're going to get you all up to date. So thanks for tuning in. You guys on Twitter tonight, so it's good to see you as always, and of course on Facebook and now on Rumble, so good to see you guys there as well. Let's see, making sure everything is working, trying out some new ways to do this. That's a pleasant surprise when stuff sometimes doesn't work out as you anticipate, but it's the way it goes. Let's see here, I'm going to update this. Okay, so everything looks good. So Facebook always likes to change things on me, so I'm trying a new way of going live. In the process of that, I forgot to turn my YouTube on. So sorry, YouTubers. They're going to be like, what? I got the notification, but he's not there. I know, and the way YouTube is, if I don't press this button first, nothing happens. It's so frustrating. Like, there's nothing I can do to fix it. So trust me, there's so many nuances in all of this stuff. It can be very, very frustrating. But needless to say, that's all neither here nor there. Okay, so what do we have out there currently? Let's go ahead and get this going. If you haven't noticed today, it was a little warm, a little toasty, right? And we're still a little warm. I've got 70, almost 74 degrees here in my backyard on my Tempest weather station with a southeast wind. At least the winds have calmed down temporarily for a little bit, so that's good. Luckily, no severe weather around here for a while, so it's been kind of quiet, but that probably will not be the case, right? So we're going to talk about how that's going to change, and it's probably going to change as early as tomorrow. And you're probably thinking, what? Where'd this come from? This is Sunday evening. I said, yeah. So you do know I don't like to talk about tornado potential until about 48 hours out because too many things can change. Well, today's a primary example of that. So this morning, the model data came in, and it said, you know what, might have a couple of supercells that developed Sunday evening right across central Oklahoma here in the metro. And those would be potential tornado makers. I'm going, well, that's a interesting change. So I'm like, okay, so let's take a look at it. So that's what we're going to do tonight. We're going to see if we're going to get a surprise event for tomorrow. So it is what it is, right? I know. It is what it is. Okay, so let's go to the next thing of graphics here. By the way, please like and share this video. Tell your friends and family about AT's weather so they can get the scoop just like you do. All right, so here's a look at temperatures out there. Currently, like we mentioned, it was not bad. We've cooled it from the 60s into the low 70s, so it's a pretty nice evening. It's really not even humid either. It's pretty dry. Now, this morning, we had a freeze, but if you've been watching me for a week since my blog, this is not news to you, but we'd hit into the low, almost lower 20s. We hit the mid-20s for sure. There's a low 20 up there in northeast Oklahoma. So It was a very cold start to the day, so hopefully your plants made it. If you procrastinated, didn't cover them up or bring them in. This afternoon, boy, it heated up. We got into the 70s out here in eastern Oklahoma and the 80s to 90s. Woo! Who would have thought we'd see 90 degrees already in the early part of April? Welcome to Oklahoma. Man, that's almost a 20-degree temperature spread there. Now, the winds out there that we talked about have calmed down quite a bit on a sustained level, but there's still occasional gusts. So here's a gust of 22, here's a gust of 20, gust of 19. So we're not done with the winds, just so you know. We're going to have more winds for tomorrow. Unfortunately, that's just the way it goes. If you do look at the forecasted wind gusts for Sunday, the bulk of the wind will be across the eastern half of the state this time around versus the western half, which is good. Because keep in mind, without any significant rainfall and significant vegetation that's on the green side, a big threat for wildfires has been continuing in this area. And so any wind speeds at all over 25 miles per hour is going to be a problem. So there's going to be a few of those for tomorrow. Not nearly as bad as the last few days, but it's still there. It's still on the docket. So don't burn. And that's where the National Weather Service reminds you, just one spark can start a wildfire. So don't weld, don't drive on a flat tire, which I don't know why you want to do that anyway. I guess it's for the big rigs. Parking on dry grass, because again, that heat from your undercarriage could get it. Throwing cigarettes out the window. Do people still use old school cigarettes? Is everybody vapor now? And then dragging chains behind a vehicle. Don't do that. Although I've seen fire trucks drag chains behind a vehicle and spark all over the place. But at least they got the hose to put it out if they start it, right? Oh my goodness. Okay, so here's a look now, shifting gears to the severe weather threat. So let's take a look here. We've got the Storm Prediction Center outline, and it does show most of the severe weather tomorrow will be into Missouri, and a lot of this will be late. It'll be like tomorrow night. That's the categorical risk. We talked about the tornado probability of it, and it extends in that area in the northeast Oklahoma. But you know what? They don't include this little area here in central Oklahoma, and I think we shall. So we will add to this and bring it back into the metro. If you're going, well, you can't do that. I said, well, certainly I can. I do it all the time. So, and they'll update that stuff too, because they do this on swing shifts, right? So I just happen to look at the latest data. When their new shift comes in, they'll look at the latest data. They may wait until tomorrow to get verification or confirmation, and then they may extend it then. So I'm not their mind reader. I'm just my own mind reader. My wife always asks me to be her mind reader, and I said, that gets us into trouble, so please don't. Little family drama there. She's gonna love that one. She's watching, of course, and typing in the comments. Okay, so this is the risk for hail and for wind. Now, I'm also going to disagree with the hail. Go figure. Any storm that pops up in here is going to be massive hail producers, and I'm talking over 2 inches in diameter. Big hail, right? Damaging hail. So that's on Sunday. All right. So then what happened to Monday? Now, if you remember, was it last week? 8 days, away from Monday, people were freaking out, calling for Armageddon. Monday's going to be bad, blah, blah, blah. Well, here's the deal. The outlook doesn't even include Oklahoma City. So it's way down here in southeast Oklahoma, and actually that's pretty far northeast. It may end up being more like this. But it will include Dallas-Fort Worth, and it will include a good chunk of Arkansas. So if you want to ask me where's a better probability of seeing tornado or supercell type activity, definitely in Arkansas, and a little bit of a lower probability here in the Dallas-Fort Worth area, but both of those areas are good. Nothing here across the body of Oklahoma. The exception to the rule will be far southeast Oklahoma, and that's on Monday. All right, now what about Tuesday? A lot of talk about Tuesday. Got to get the hype machine going. All right, well, Tuesday, Storm Prediction Center does highlight the eastern half of Oklahoma, but if you noticed, where it likes the more favorable region, it's just on the east side of Oklahoma City, up through Tulsa, and therefore onward. Now, we talked about that in prior data. That's fine. We're going to look at the details, though, and see if we'll actually get storms, because there should be a pretty strong cap, which may mean no storms at all, at least for central Oklahoma. We'll see. All right, then we go into Wednesday as the storm system starts to depart. Remember, timing is everything, and right now it's coming in pretty early in the day, which means by the time it gets things going, it's all east of us in the far eastern Oklahoma. So probably about the eastern third of the state's got the best probability of seeing nasty severe thunderstorms that could produce a couple of tornadoes, and right now that is mostly centered over Arkansas. So honestly, this is mostly an Arkansas event as far as 2 of those 3 days for seeing some at least decent parameters to produce severe weather. If you want to break that down here from the National Weather Service in Norman, they do include central Oklahoma a little bit more for wind speeds up to 60. I'm going to bump this up though. I like this idea here. There's going to be a few of those falling from the sky if these storms can get going. As we head into Monday, far southeast Oklahoma, and again, that might even be pushing it. It may end up being more like this region down here. But we'll find all that stuff out a little bit later. And then as we head into Tuesday, here's a close-up view, again, kind of on the east side of Oklahoma City. And this, of course, extends into eastern Oklahoma. They don't include the Tulsa area in their graphics, but it does include Tulsa for the guys asking. And then the Wednesday risk, slight, because most of this should be early in the day moving out. So storms wouldn't have that much of an opportunity to get going by the time they move through most of the state. Okay, so right now, as you look at the water vapor channel, this is the satellite view. This guy right here is a weak disturbance, a lot of upper level ripples of energy, all right? Well, that is coming its way eastwards. That will move through the state tomorrow, and that will be help to trigger some of these showers and storms out there. All right, so now let's go to our next little map here. This is the upper levels of the atmosphere. This is a jet stream pattern. The colors represent lift in the atmosphere, so clearly a ton of lift up here across the northern plains. But we got just this little baby lift down here. It's not much to write home about, but it's there in a west-southwesterly flow aloft, so it's good enough. It'll do the trick. Now we have a dry line and cold front, warm front interchange coming into play. So it's going to look something like this. All right, so that would be our stationary part of the front, which we'll call it a warm front because it may actually move to the north a bit later in the evening. Cold front, something like this. And so where you have the brighter colors, that's lift along the cold front. Always a lot of lift, low level lift along a cold front. And then we have this little batch of colors down here, and that's the dry line. Dry line just separates the moist air from the dry air. Also gives us kind of a southwest wind in this region, whereas in here you have a south to southeast wind because that feeds into the triple point. So as I mentioned in my post earlier today, if you saw that, we talked about the triple point being a focus area for some nasty thunderstorms. And guess where that puts those? Right here over central Oklahoma. So that would be the favored area for initiation for right around, let's call it 7 o'clock would be the sweet spot as far as the timeline. So let's see how that looks when we're talking about dew point values, right? If you watch here, you can see how the moisture surges out of the Gulf of Mexico into Oklahoma as we head into the 7 o'clock time frame. And these are those 60-degree dew points. So that is where you need to get the really good juice that moves into the state, and that is what you need for tornadoes, believe it or not. Very hard to get a tornado when you have dew points in the 50s. Now, west of Oklahoma City, this is Canadian County right here, you can see dew points drop off pretty quick into the 50s, upper 50s, mid 50s. Now remember, it all depends on where this little area of low pressure is for that triple point, but what it's going to do is start to pull this deeper moisture back toward it right around 7 o'clock and onward. So this will continue to work its way into central Oklahoma. So it's kind of like a very last minute moving in, just barely. So there's 8 o'clock, 9 o'clock, 10 o'clock. You see how that happened? You see how the dew point deepened? That's a measure of raw moisture in the atmosphere, and boom, boom, boom. They just keep moving. That's that. See how they move northward? That means that front that I talked about is moving to the north a little bit more, drifting to the north. So any storm that is developing and anchoring along that frontal boundary gets to feed into this pooling of increased low-level moisture. That is also a tornado enhancer. Now here's a close-up view of that without the numbers, just the winds overlaid. And this is at 7 o'clock. So this is where our high-resolution short-term models come into play, because each one is going to say something different on the final position of these frontal boundaries. And trust me, that makes all the difference in the world when you're trying to pinpoint locations of where storms are going to initiate. So right now, the way things are setting up here with this particular model, which we're going with here for tonight to kind of show you how things are going to evolve, kind of shows you that this region, so this is Oklahoma County. I would advise you to learn your county shapes, by the way, when you live here in Oklahoma. This is Canadian County. So your favorite area is always going to be along this warm front and down here to this triple point right about in this zone for storms to initiate and develop. Now, they will form a little closer to the warm front zone, but I'm just giving us a little playroom here. So it really depends on where this front ends up being. Because if this front's a little bit more to the south, say along the I-44 corridor, which is where it had it early this morning, that means any storm that rides along that boundary, guess where that's going? Right through Oklahoma City. Now, I will tell you this, a lot of times we have significant tornadoes when they can take advantage of the horizontal vorticity along a cold front. It's just extra spin in the atmosphere. Updraft will take that up, use that extra spin. When it comes to tornado already, it'll use that extra spin. It'll help make it a little stronger. So it's very critical where that boundary sets up. So could it happen here in Oklahoma City? Of course. Could it happen a little bit more to the north? Sure. Where we find these exact positions where the front lines up is not the night before, I'm afraid. That gives us a general idea, but it's the day of and probably 12 hours out is when you start to see that kind of deal happen. So I'll be watching obviously tomorrow to see where that final position is, but wherever near that warm front is, that's the track you really got to pay attention for tomorrow for big hail and a potential tornado. Okay, so let's go to the shear value. So look how this is cape and shears where you have the instability and the shear that develop. Now, the brighter the colors equals the more instability, so the greater the cape values. Anything over really 1,000 is fine for tornado development or severe storm development, and we've got 2,000 to 3,000, so we got plenty of instability. The shear, this little guy right here. So we'll take a look at this. See this little right here? You have the red arrow that comes from a southeast direction and the black arrow from a west direction. So that's like this, right? Well, that's a lot of turning with height. That's a big vector. So the bigger the vector, the better the turning with height in the atmosphere for these storms to feed off of, which is, again, conducive for tornadic development. Let's see, what else we got here for you? When you do factor in those ingredients, we'll take a look at the significant tornado parameter. Now, I'm going to start you at lunch. Watch how this thing increases. See how the colors get brighter? See how everything kind of moves to the north? So we actually have an increase in the tornado parameter as we go through our evening here over central and southern Oklahoma. Now, you can have the ingredients that kick up the parameter, but you still have to have a focus. In other words, you have to have a trigger, a kicker, and you have to focus those low-level features as to where in this overall environment is the best shot at seeing that type of weather, and we've already kind of outlined that for you. Okay, so this is what the model does now. Now, early this morning, it produced a couple of supercells right through Oklahoma City area. This time around, if we go to 7 o'clock, we'll start here. It tries to get something going, but it just doesn't have much luck out here just west of town. A couple areas that it highlights, they don't seem to do very good. They kind of vamoose, or vaporize rather. And then by 9 o'clock, it's got more elevated activity as the front starts to lift to the north, and it has a little supercell that quickly goes up and produces already a helicity track with it as it works from west to east, just north of Oklahoma City. Now, the potential with this is going to be for some large hail still, overnight, Sunday night, anywhere where you get a big supercell storm. We're talking 2-inch plus size hail in a lot of these, so that's going to be some big hail makers. Other elevated storms, which will be hail containing up into southern Kansas and northeast Oklahoma, so do expect a little bit of severe weather for tomorrow, late evening here across northeast Oklahoma and along the border of Kansas, with most of these being hail makers. Anything, though, however, is along that frontal boundary could produce a tornado in that area. Now, the front itself will move on through, get a good push, shove all the precipitation away. Here's Monday afternoon and evening. It doesn't even really get things going at all in southeast Oklahoma. Kind of just a few scattered light showers and maybe a rumble of elevated thunderstorms, and that's about it. It doesn't do much for that region. But let's take a bigger look. Let's expand our view, and we'll see what happens. I'm going to show you another model here as we go through the time. So again, this model also tries to fire off a few thunderstorms that just don't quite make it, but I think that might be an error. Let's see. Let's go to 7, 8 o'clock. You can see some thunderstorms down here near the Dallas area. There's that one here in northern Oklahoma along that warm frontal boundary, because it also tries to move the front to the north. And that moves up into Kansas, so some good thunderstorms there that move through southeast Kansas and also to Missouri, but we already kind of highlighted that Missouri area on the Storm Prediction Center outlook. All right, front moves on through, then what happens on Monday? So this particular model, blows things up here across Dallas-Fort Worth. It does have looks like a supercell or two across far southeast Oklahoma. That blows up there. Those continue in North Texas. And then Arkansas lights up like a Christmas tree during the latter part of the evening with a cluster of multicellular and supercellular storms in that region. Likely probably some large hail, and yeah, probably could be a couple tornadoes with that. So that's kind of how that looks on the bigger scope of things. When I look at the Texas Tech model, which I like to look at during the spring season, doesn't really fire anything off for that stuff out to our west. It holds it off to elevated stuff that develops. This is probably, about 10 o'clock, 11 o'clock up here in northeast Oklahoma. It does have helicity tracks with it, which means these are expected to be hail makers. And if the front is in that vicinity, the warm front, you got to watch out for a potential tornado there in northeast Oklahoma as you approach the 10 to 11 o'clock hour. So that's what this model suggests. Now, on Monday, same idea. It likes the North Texas area. It likes the Dallas-Fort Worth area for some supercell storms. That may produce a tornado. Southeast Oklahoma, it does try to produce something there. It didn't have much luck. And then it's got some more storms that bubble up in Arkansas. It's not very excited about that region for some reason. Maybe because the cap is probably a little strong, but that's the way it looks for Monday. And of course, we'll take a look at Monday, as we get closer to the time frame. This particular panel here, let me see if this new data has come in yet. It has not. Usually comes in late. Now, when you blend all the model data together and you try to find out rain out of all this mess, who's going to see it? Well, they're not going to see the potential I'm talking about, which is a few supercell storms breaking out, in this area and then moving east, right? Or even up here and moving east. So this is going to discount those. What it's going to do is kind of average all the other models together for the long term and the general consensus of best rainfall amounts. And it's going to keep that confined to basically the eastern third of the state, which means it's got nothing out here for western Oklahoma, and a big question mark here if we get anything measurable here in central Oklahoma. Now, again, I believe we'll break the cap and we'll see a couple supercell storms. Could be in the metro, could be near, just by, close by to the north. Just depends on where those surface boundaries line up for tomorrow. So don't be surprised you see something go up, and it'll go up fast. That storms that develop 15 minutes to 30 minutes, it'll be severe that quickly, and it'll start hailing almost immediately. The lapse rates are ridiculous. So it will be a big hail maker. All right, so somebody asked me earlier, Facebook, are we done with the freezes? Tough, man. That is a tough question to ask in April. So this is the European model, and this is for Tuesday, April 19th at 7 o'clock in the morning. Just to show you, and I mentioned this in the blog, it liked Easter weekend for another cold morning. And I know most of you say, oh, you always wait till after Easter to plant. But the problem is Easter comes various weekends from late March to April. So you never know when that's going to be. So in this particular case, it actually is going to hold true because we might have another light freeze for some of you out here across the state on Tuesday, especially out west and northwest. But there's still plenty of time to see if this changes. It's kind of been a little inconsistent at times, so not completely sold on it, but that kind of gives you the idea. Now, temperatures. It was obviously a warm day today. Tomorrow, also another warm day. Monday warm, Tuesday warm, and then really nice next week on into the following. Now, overnight lows, we get chilly again Thursday, so there'll probably be a few upper 30s, some low 40s. I guess in theory could be some patchy frost if we have light winds and clear skies. I did not check, but a little chilly. Otherwise, some decent morning lows there. And then here we go as we head into that morning from April. Early, let's see, on the 18th, 19th, some cold mornings here, so we'll have to watch that. But if you do have tender vegetation, basically the bottom line is just be prepared to cover it up with some burlap or move it in. All right, I have covered all the main talking points in all this. If you want, I can teach you some meteorology. We can look at just one model, and we can show you all the different parameters that catches my eye that says, you know what, I think we're going to have a couple of supercell storms break out here in central Oklahoma. And a couple of those will be hailers at first, and then as they get into deeper moisture moving east, and then get in closer to a warm frontal zone, maybe produce a tornado. I can show you that. Those folks that are interested. But as far as the main big gist of the forecast, that is completed. Then I get into a whole lot of details for, you know what, let me do this. There's one thing I did not do, so let me do this. Hold on. All right. So this is 7 o'clock. I'm going to pick the forecast sounding for Oklahoma County just at that point in time. All right, just to show you what the forecast is in the sounding data. At this particular time, we're starting to get a little bit of a light cap. This little nudge in the red line is a cap starting to build. So we have a very short window at getting thunderstorms to develop and then move through this area. So if they don't develop in time, the cap will build in and that'll shut down typically anything surface-based. You can get an elevated thunderstorm though at this layer because of the warm front usually, and that's probably also what the models are hinting at. That comes in later in the evening. But the shear is turning with height is pretty decent on the directional shear. Speed shear just a little weak in this one particular spot I picked on the map. But if I picked others, it would be a little better. And the speed would be a little bit better too. It really all depends on the timing, like with the low-level jet kicking in, etc. So like, for example, this particular case here at 9 o'clock. Let's say we have storms that develop at 7. They're not moving that fast, about 20, 25 miles per hour. They move across all of Canadian County. Then they move across Oklahoma County. All right, it takes them until 9 o'clock to get here. So this is what's happened in that time frame. The cap is built in. Look at this strong nudge here on the red. So that means the cap is solid. So which means that you can't get any new storms to develop. So you have to have existing storm already rooted into the boundary layer, and it has to survive as it gets into this more hostile environment. So what's going in its favor to keep it going? Well, this shear, although a little messy here, has great speed and directional shear at the lowest levels, and the storm relative felicity is increased back into almost 300. The SHIP model, which is 2.9, indicates some very large hail, with the lapse rates up around 8 to 9 degrees Celsius per kilometer. So big hail, big strong storms. So this is adequate enough, again, especially if you throw in a little vorticity from a boundary, to get a tornado to develop here in Oklahoma County, for example, or even through this little axis of central Oklahoma. So that's kind of what we're watching at, and this is, again, 24 hours away from the, in the data. Tomorrow morning's data will be a little better, more accurate. Then the lunchtime data will be even better as far as fine-tuning this kind of stuff. But I want to bring that to your attention. Just that's a little bit more detailed, nerdy side of meteorology. All right, let me go to a couple of your comments and questions. And again, sorry for you guys that joined from YouTube. I pressed the wrong button, so I didn't get that up and running. There's so many things I have to think of to do, and sometimes my brain doesn't get them all because it's a nightmare, logistical nightmare. That's all right. We're gonna do it as long as I can do it. Okay, so let me scroll through your comments there on Facebook. By the way, some of you may have seen I am getting prepared to do a severe weather classroom chat, right, with you guys. So that's going to be on, right now I've got it set for Thursday. So after all this mess goes through, so we don't have to worry about it. So it'll be on Thursday on was that the 14th, I believe? Take a look here. Yeah, so Thursday the 14th at 8 o'clock. So I'm giving my severe weather presentation. We talk about severe weather in detail, about what the threats are, what to watch for, safety. It's a family, kids type presentation that everybody knows what to do, what to look for. It's educational. We talk about lightning, hail, tornadoes, flooding, all that kind of stuff. So make sure you sign up for that. If you're a current supporter, Facebook fan supporter, Patreon, Subscribestar, all that stuff, you guys get to watch it for free. This is a small fee if you aren't a supporter, but you still would like to get the educational level, especially for the kids. I would definitely sign up for that. I think if I do it now, if you sign up, it's like $5, and then so that's nothing. Just a cup of coffee, and then so we'll do that on Thursday. So it's on my weather page right now. It's on the wall. So make sure you sign up for that. It's under the events tab if you want to click on the events tab. Let me think. What else? Frozen on the screen over there. There we go. Why did I freeze? Man, I've been having so many computer problems lately. I'm just like, just get me through the severe weather season, buddy. Just come on, you can do it. I've checked everything, rebooted, reloaded. I don't know what's going on. It's old. Let's see what else I got for you. I'll be doing a live for your Sunday, obviously. The time, obviously it'll probably be right around lunchtime, so literally, it could be like 12 o'clock, something like that. So when you guys get out of church, make sure you tune in. So I'll wait, because a lot of you do go to church like at the 10 o'clock hour or 11, so you don't get out till lunchtime. So I'll do it probably right around 12 or so. So that's after all the new model data's come in. And then I could kind of fine tune where those low level boundaries are. All right, got Jody. Yep, I'm glad she said that. Make sure you download my weather app, AT's Weather to Go. And it's not a shameless plug. Honestly, if you don't want to use it, you're not going to hurt my feelings. But I'm just telling you, you'd be foolish not to use it. And why would I say that? Well, one, it's free. Doesn't cost you anything. But two, it actually predicts tornadoes. It's like me in your pocket. Like I predict tornadoes, it will predict tornadoes just like I do, just differently. Up to about 15 minutes before an actual warning happens. Why? Because it knows when a tornado is about to come down, because it uses a proprietary basket of information that predicts that activity. And so what happens is you get a twisting storm alert, and it gives you a kind of, think of it like a confidence factor. So on a scale of 1 to 10. So you get a danger storm approaching. It'll say like a BTI of 4, right? Or 6 or 7. All right, that means that it's got a probability of a tornado in there, right? But it doesn't necessarily mean that the tornado is going to hit you. When you get that warning and it changes to a twisting storm alert, that means you're in the direct path of the tornado, which means you're probably ought to hit shelter. Now, with that, you're going to have a number. If it's like a 1, 2, 3, it means low probability, watch it. If it's a 4, 5, or 6, it means you can still watch it, but you better start getting ready. And if it's a 7 or higher, hit the deck. Don't even waste time. Get in the shelter. You can watch later. So that's how you interpret those numbers. It's a confidence level, so it's a scale. I've never seen a 10. I don't want to see a 10 because that means that's bad news. But anyways, you're going to get those kind of warnings if you use my weather app, AT's Weather to Go, Apple and Google Play. But so thanks, Jody, for mentioning that. Yep, somebody's already talking about YouTube. I knew they would. It's okay. It's okay, Aaron. It's okay. Next time. All right, so those folks that are still hanging around, I'm going to do a little quick weather lesson for you on severe weather analysis. All right, you like that? You want that? Good, let's do it. Okay, so let me do, where do I want to start? Let's do this map. And we'll do 24 hours. Okay, so I'm going to teach you, when it comes to severe weather, a few things to watch for. And we're going to have to go to this guy. All right, so first off, you already know the big ingredient's moisture. Without moisture, you got nothing. All right, so dew point values coming in around 60, nudging here in Oklahoma City metro area, and then from that hour after. So from 6 to 7, we really start to moisten things up, and we stay moist after the fact. Okay, so that's one thing. And we have to have a south-southeast breeze to help for tornado genesis, and we do. We have these winds that are kind of coming in from a south to southeast direction, and they go back to this direction because we have that triple point that's formed out here, right? And then we have the actual warm front that extends out of that, which is the boundary for any storm to kind of ride along. Okay, so that's what's going on with that. We kind of talked about that already. So now let's do a few other things. What's favorable a lot of times is to see a mid-level speed max at 500 millibars. So we're at 500 millibars, and the purple indicates, yep, this brighter color indicates a nice speed max moving through the state from west to east. That helps to boost thunderstorm development, gives it a little extra lift in the atmosphere. A lot of times we look at the upper levels, like for jet streaks, like the overall jet stream pattern for entrance regions, exit regions of the jet. For us, we're kind of in a split pattern, so it's not, it's just neutral. There's not like excitement one way, it's not like depression the other way. It's just like, it's decent. It'll do the trick. All right, so now let's go to, I think, 850 millibars. So in this particular case, you also need the strength of a good, strong surface wind, but not quite at the surface. In other words, something that's about like a 1,000, 2,000, 3,000 feet up. So you want a good, strong south wind to develop. Now here at 7 o'clock, we've got one starting to develop out here in southern Oklahoma that's moving to the north, but it kind of cuts off, right? Didn't quite make it to the metro. If you go an extra hour, see how this happens? Boom, It just goes from nothing to super strong. That's a screaming low-level jet that comes in during that time frame. So low-level jets kicking in from the south to help those storms, give them a little boost to keep going. All right, what else we got going that we care about? Moisture is always good, of course. We kind of highlighted that with the surface dew points. We did talk about the vertical velocities at 700, which means a lot of lift along the dry line. That's this bright colors here. As we go through time, you'll see that lift kind of moves along the front. So the warm front gets all that extra lift too. So any storms riding along the warm front takes advantage of that extra lift. All right, so let's see what else we had. Let's do some of these. Lapse rates. These are good ones. Okay, so this is a lapse rate at 7 o'clock. So 8 degrees, which is what you see here on the map. This purple is 9.5 degrees. All right, so the bigger the number on lapse rates, usually the bigger the hail, but also the faster and bigger the storm can develop and explode. Lapse rates, when you get up to 7, 8, 9, off the chart. I mean, storms just go from nothing to gangbusters quick. Lifted index at this point in time. All right, so lifted index is a combination of other factors thrown in. They give it a value in Celsius, but the colder it is, the bottom line is, or in this case, the brighter the color on the map, the best lift, which means the highlighted areas where you want to pay attention for the ingredients to come together to produce some storms. All right, now, will there be a cap in place? Now, we showed you that in Oklahoma City, one was starting to build around 7 o'clock, right? But along that front itself, and I'll circle this right here, this little zone right here, into where the triple point would be, there's a weakness in the cap. In other words, there's a lot of lift here, so there will not be a cap, and this is the area. All the way back to where the triple point is, a little surface low out here. So this is why this is a favorite area of development for storms. All right, what about cloud bases? So initially, any storm that develops in a cloud base with a lifting condensation level, which is LCL, the heights, out here in this zone, closer to the triple point, this little quadrant here for Canadian County, you see that goes into kind of a red, orange and red area. Well, on the map, that correlates down here to 1,500 to 1,700 meters. So in other words, that is too high. In other words, a very high cloud base. You don't get a tornado in that environment, but you can still get a nice looking supercell structure with a lot of hail. So that's kind of how that starts out. In other words, a hail maker. But what happens is, as you go through the next few hours, those cloud bases come down. And all of a sudden, we're now down at 200, 300 meters by the time these storms start to roll through central and northeastern Oklahoma. So now the cloud bases have come down, it's a lot easier to get a tornado to touch down, all that kind of stuff. You still get the hail, but the environment has changed dramatically because more moisture, low level jet, all that kind of stuff. All right, so now let's see what else we got here for you. We did talk about the Cape earlier, but you do want to go where the Cape is maximized. In this case, Canadian Oklahoma counties. Nice little sweet spot here. Cape in the 1800s to near 2000, even down here along the dry line. But down here, I'm just going to click down here, by the way, to show you what's happening in southwest Oklahoma. In this particular case, the cap is kind of strong in this region a little bit, and that's precluding what the models think will be any storm development. So it's not, it can't develop down there. It's just, it's a lot less likely because these values here, these little SIN values, are over minus 200. And usually anything that's over about minus 100 isn't breakable. Minus 50, no problem. 25, minus 25, you can break it easy. Minus 75 is already questionable. You gotta have a lot of good, strong dynamics. So at that point in time, it's just too capped down here. So the better shot is up here closer to the surface low. All right, let me see what else we got on here. Oh, bulk shear. So you got to have bulk shear to get tornado-producing storms. And we're looking, you really need about 40 knots, and we've got 53, 52, so we got plenty of bulk shear. Storm relative helicity. This will actually increase along the frontal boundary. So if I were to go to the next step, you see all of a sudden it just exploded. This is in the 300s. That's why I'm saying once you get out of the... About 150 is like the bottom end. 200 is better. Anything above 200 is just icing on the cake, and we've got plenty of that to go around. All right, so now let's look at the supercell composite. So supercell composite is where you take a look at all these other indices and you put them all together, and you see the probability of seeing a supercell type development or a storm. And of course, as we go through the evening hours, that's right across this favorite area that we've been talking about. So it is a favorite environment for supercells. What about the significant tornado parameter? So this one is questionable. This is where it's only going to pick up where it has vorticity boundary interaction with the front. And that's kind of in this zone here, which is through the heart of Oklahoma, and then up north along the front. So that's where you have any potential tornado in this region. There's just a little extra boost there for a significant tornado. Outside of this, you don't really have an environment for a significant tornado at the beginning or even really during the event. So without that boundary interaction, it would be a weaker tornado. EF0, EF1 kind of a deal. All right, so the Cape, we'd already talked about that. We talked about the shear, the difference in the turning with height. Let me see, I went an extra 9 hours, or excuse me, extra 3 hours to the 10 o'clock frame. So what happens is, okay, so let me do this for you again. So when you get this little red arrow kind of going in this direction, right? And here's a black arrow going in this direction. So that's what we say, this is your angle, so the old geometry. And we're looking at probably about 100 and maybe 60 degrees of shear, of turning. It's 160 degree turning. And then that usually means really good conditions for spinning storms, for supercells. So this is how you look at it on a vertical, as though we had launched a balloon. We're looking all the way up into the atmosphere. Again, there's our surface. There's the southeast wind. Remember, there's that wind that we talked about coming from the southeast. Then you have to envision going upstairs, and then you get that black wind, which is this guy up here, out of a southwesterly direction. So you can see how these winds then turn from southeast to south to southwest. That's what you need. It's a staircase approach, and that's what helps you get the shear going in the atmosphere to produce tornadoes. So the more turning you have and the stronger the winds, this is speed shear here. This is 30 knots, 35 knots, 40 knots, 40 knots, still 40, 45 knots. So the stronger the winds, as long as they're not too strong, if they get too strong, sometimes they can rip things apart. It's just too much air movement. But this is a good wind speed to sustain a nice supercell structure for a tornado, to make it a little bit more, what word am I looking for? Stable, I guess. In other words, you get a tornado that develops and it's not in an unstable environment as far as falling apart or getting ripped apart or whatever. It's kind of more stabilized for it. So once it gets going, it has a chance to hang around for a little bit. Not just a quick little 1 second touchdown. Okay, so I think those were the majority of the things we looked at here for tonight, which was enough. So bottom line is, when I see this and I see that the model really didn't produce a supercell, but I see all the other parameters are there, I go, ew. I go, if it's tough, because if you go with the model, and you go, all right, dry here, no big deal, and then all it takes is one little parcel to go right through everything I just showed you, and it's Katie bar the doors Armageddon. So just because the model doesn't have the output of the storm doesn't mean it's going to happen. We look at other ingredients and we say, I'd call for a few storms there. An isolated storm or two is what I would do. So that's what I did here for tonight. And the model did finally produce one a little bit more north of Oklahoma County. So I'll tell you what, I'll show you this. Let's go in closer. And let me show you what this model looked like in the morning. Let's see, for the same time frame. Is it this one? Yeah. So this was 9 p.m. 2 supercell storms producing a helicity track, which indicates damaging wind, large hail, and potential tornado in this environment, right through Oklahoma City, right along I-44. And I was like, that'd be a problem, right? So I better start paying attention to this and looking a little deeper into it. This model is an outlier compared to a lot of them as far as some of the ingredients and the placement of certain features, etc. So what's been the trend? Well, the trend I noticed today from different models was either the front's in this position, or it's in this position, or it's in this position. And I'm like, okay, well, that doesn't really help me, but we're still pretty far out, so that's expected. Tomorrow, like I said, we'll know the exact position as best we can within probably about 30 miles of where that front will be for who's going to be under the gun. And of course, during the event itself, we'll be able to track that and tell you exactly who'll be seeing any activity. All right, so that was the morning run. If we go to the midday run, what happens? This is where it started to get a little confusing because now it still has one storm, but only one east on the northeast side of the metro. But then it starts to build that secondary storm up here, right? And then let me back it up an hour. Let's go. So there we go. So there is, I had to start a little earlier, so there's 7 o'clock. It already has a supercell storm with a helicity track on it. And let me show you 6 o'clock. Nothing, right? So from 6 to 7, it went from nothing to a supercell storm already with a history of producing large hail and potential tornado. And here's a look at that forecast sounding. So it's got a marginal tornado with an EF2 strength of the potential tornado. Ship model of 2, which means hail up at least 2 inches in diameter. Nice turning with height, good wind speeds, but a kind of a high LCL. So it's not. I like LCLs about 1 kilometer or lower, and this is a little high. But regardless, that had a pretty decent little storm moving through Canadian County at 7 and through 8 Oklahoma County. It kind of fell apart, but it kind of keeps this northern guy going, probably because it's lifting the front northward. So without the front to hang on to, which is kind of what it was doing in Canadian County earlier on, the storm doesn't have as much with it and it falls apart. And it's a good thunderstorm, but it's not as destructive as it was prior. And then if you notice with the front moving northward, then it starts to bubble up a new development around 9 o'clock, 10 o'clock, and then that kind of continues overnight, Stillwater, Tulsa area, northeast Oklahoma, blah, blah, blah. All right. So you can see how the trend has been. So let's go back now to the model data that came in this evening. 7 o'clock, nothing. 8 o'clock, nothing. 9 o'clock. Okay, now we got something, but now it's way up here because everything's starting to lift to the north and west, a little more elevated, so probably more of a hail maker up there. And then that one actually dies out. So I'm not sure. Let me think here. Unless it has this thing moving due southeast, which would be a hard right turn. If this is that same cell, it's hard to tell when it's got a 1 hour jump in time. It probably just died that one out and developed a new one here, just north of Canadian County, so right around Kingfisher. Anyway, so that one moves out to the east, has a little helicity track to it as it heads towards Stillwater, which is kind of right around where that warm front would be. But it starts to fall apart, and it starts to now focus way up here in northern Oklahoma. So that's just the one model that kind of sounded alarms that, hey, you might want to take a look at this. But even then, you can see how it's not really sure how things ought to go. So when you're the forecaster, you're trying to make sense of all this. You're trying to tell, all right, well, who am I going to tell to take cover or to get ready, you know? But luckily, when we're 24 hours out, you don't have to be that specific at this point. Just know there'll be storms in the area. And then the day itself, we'll get more details on that. So that is kind of how you would look at some of these technical indicators to look for potential severe weather development. So I don't know if some of that went over your head or some of it went right to your brain and you've saved it and you now have a brain cell filled with Meteorology 101 and you can use it at the dinner table. Maybe you got that. Dee Dee's back home in Oklahoma. Yeah, you haven't missed much. Weather's the weather around here. Okay. So Terry, if you've got the app, you're good to go. You don't have to know how to work the layers map. If you don't want to, it'll still tell you about the tornadoes coming. But the map, just play around with it. Just tap all the buttons you can find. In the layers, if you go to the map itself at the top right, there's a little layers icon. You tap on that. You can change all kinds of products in there. And at the bottom, there's a legend that's usually color coded. You can tap your finger and drag along that legend. It'll tell you whatever the readout is, and that goes with whatever's on the display. So that's how you can do that. And then if you tap in the different layers, there's overlays for like lightning, arrows for storm development, storm direction. You can click on those arrows, and that'll tell you additional information in the storm. So there's a little box on each arrow, severe weather arrow. And that'll tell you if it's got hail in it, a tornado in it, how big is the hail. It'll give you a forecast for your time of arrival. So there's a lot of information. It's like Easter eggs in there. You just got to keep digging, and you'll find stuff. Go down the rabbit hole, and you'll find some stuff. Let's see, what else? I will tell you this. There is I'll show you this. Let me just show it to you. All right, so we are now at my website, aarontuttle.com. So first thing on here was my interview spotlight with Jamie Ferguson from Ferguson Roof Systems. If you guys missed that, you have any roofing questions at all, like what do you do when you get to file a claim, all about insurance, all about what kind of roof, what kind of shingles, you name it. There was a 30-minute Q&A. A lot of you guys that watched it live sent your questions, and we answered them all. So check that out, sit back, and you'll learn a little about roofing. He doesn't shy away from any questions. So if you ever want to pick a brain of a roofer, there's your chance. Okay, so anyway, in here, if we scroll down, interactive, this is under the weather data tab, interactive weather radar map. So I just updated this on my website, and my weather app is going to get a similar update. It's coming out soon. But it's an overlay from the maps that works a little differently, which is nice. So in this particular case, by the way, there's also a map overlay button right here, just like there is on mine on the phone. And you can have radar, satellite, lightning, storm tracks, alerts. Now this is what's on here that's not on my phone, and that is future radar. So you can click on future radar, and it'll take you out. It's a short term, so it's not made to go like 2 days in advance. It's just made to go for like a couple of hours. So let's say we've got some nasty storms, and you want to find out which way they're going. Not where they've been, but where they're going. Then you just hit future radar, and that'll give you the idea of the track that they're going to go on. That algorithm was developed from MIT years ago. So it's used from a lot of weather companies to show where the future radar is going to be. So let me see if we have any. All right, so here's an example of that. So we'll just go up here. These aren't really storms, it's just rain, but same principle. So if I hit the old play button, you can see how it's going to move things forward in time. So that kind of gives you an idea of where they're going. So that's future radar. All right, and then back to national. And then they got lightning on here you can overlay and some other things. But this is what I want to show you. So you come up here and you go to Rapid City. And if you keep zooming in, now with the map overlay, currently, like on my app, you have to slide the transparency to like 75% so you can see the roads underneath. This time around, I'm going to have the roads on top, so that like this is here on my website. So that way, it's easier to spot out town names and roads without having to mess with that transparency. So you can keep it full opaque if you want on the map. So that'll be coming out any day now. So it's almost ready, but that's just an example. You can get a quick preview on my website, aarontuttle.com. And this has some other things on there. And all these little high-resolution radar sites, these are all for Oklahoma area. Central Oklahoma, southeast, northeast, northwest. In there, you can hit the velocity button. Now, velocity button, for anyone not living in Oklahoma, would probably never touch that. But you guys are used to seeing velocity data all the time now. Red and green, red and green. So you can track those little tornado circulations using those velocity data outputs on the radar. So if you want to get a little geeked out, you can just check that out. And it's on my weather app too, but that's what those mean. So if you ever want to touch on those, you can do that. And then you go back to the national radar in the map overlay button. So all that's on AT's Weather to Go or my website. All right, let me see if there's anywhere. By the way, thank you for the stars tonight. I really appreciate that. I always do when you guys send those. You guys can support me any way you see fit. If it's just liking stuff, sharing it, talking about it, wearing my t-shirt or whatever, it doesn't matter to me. I appreciate all the love you have in whatever form you want to give it. So we're one big community, helping each other out. And the whole idea is to get accurate weather information without all the drama. And that's really the bottom line. So you can't ask for more than that, right? Because I know a lot of you have anxiety and getting worked up from for people in this market. Everything's out of control. So I'm the sane yoga master of just breathe. It'll be fine. So let's see. So Rena. So she's talking about seeking shelter and all that kind of stuff. because there's a lot of you folks that don't have a storm shelter, right? And you don't have to have a storm shelter. I know it's nice to have one. It's peace of mind. If you do, you're good. So your house itself is a storm shelter. It's just a really big one. In that way, that's the reason why you need to be in the middle of it, not on the exterior of it. So you want to be away from as many walls as possible, as many windows as possible. Because there'll be flying debris, windows will shatter, stuff will blow in, right? Because remember, the winds are howling out there. So the stuff, you get little pebbles and stuff flying at 40, 50, 60 miles an hour, hit you on the face, is going to make a mark. So that's why you protect yourself with anything you got, blankets and pillows, mattresses, because you let all that absorb the flying debris. And then you let the structural integrity of the house itself protect the center part of the home where you're going to be, and the lowest floor. So, and know that in most cases, trails move rather quickly. So it's not like they just sit there on top of you until the entire house is gone. In most cases, they're all here, gone, and that's it. And on top of that, it's weird on how a tornado works is, you got this cone that you guys are used to seeing, right? But within that cone, there are little mini vorticity centers, like an octopus with little octopus arms that just spiral around. And it can be 1, 2, 3, 4, whatever. So it depends on how big the tornado is. But in that particular case, that is how you can have a big tornado that moves through two houses, right, side by side. And one, like maybe half the house has been damaged, and the other house is just left standing. And then it goes on to the next. Well, because it was one of those whipping vorticity centers that just hit it and took out a corner of it, for example. And they're very small. I mean, we're talking really small, but they're very strong, very powerful. So that's kind of how the inner workings of a tornado works, which is also kind of why if you got, so say that happened, let's take the house that had, the living room removed, the outside wall of the living room, and you got the fireplace, and there's all these little trinkets still standing there. You just had winds blowing through there at 100 plus miles per hour, right? You're like, how in the world is a trinket still staying there? Well, even though that whole big tornado itself was going through, not all the winds within that are at 100 miles per hour. So it's those little bitty guys that come in there that zip through. They're very compact, very small, with little fingers. So that's kind of how that happens, even though it's really strange. It's hard to wrap your head around. All right, so I see there are still questions here coming in. I have missed it all. Mary Kate and Ashley. So the deal with that is potentially. So tomorrow, right around lunchtime, I'll do a live. We'll find out where the position of the triple point and warm front is, because that will be the critical boundary to find out where the track of any of these storms that develop will be. So what I'm expecting here is what I envision is 1 or 2 supercell storms develop near the triple point along the warm front, moving through central Oklahoma. Question is, does it move right through Canadian Oklahoma County, or does it move just a county to the north? So that's kind of the idea. Or is it from way far south and moves through, say, south of the metro, say on the Norman, Newcastle region? There's a little play there in tonight's data. So we'll look at how tomorrow morning's looks, and then we'll look at real-time positioning of the front and pressure increases and all that kind of stuff to see if it's put the brakes on or if it's going to keep going, all that kind of stuff. So that's where we do the mesometeorology there. And so I'll do an update that, and then we'll kind of fine-tune where that is. So expect the storms to have some large hail with them. So these will be hail makers if they get going. And then any storm that gets going even later in the evening, and overnight across, say, north central, northern Oklahoma, northeast Oklahoma, southern Kansas, those will all be hail makers too. They'll be pretty decent. I mean, we're talking a lot of golf balls. There'll be some stones in there bigger than 2 inches. And then they'll move on off into Missouri and Arkansas by daybreak. And the front itself will clear us out for Monday, which means it'll be far southeast Oklahoma is where that front's going to be. And that forces all the severe weather now down into that region, to North Texas, like from around Dallas, northeastward into Arkansas. So then Arkansas needs to worry more about Monday than we will here in the body of Oklahoma. There's a chance you can get a supercell rolling through the southeastern county there. That's going to be about it for us. And then on Tuesday, we shall see if the cap breaks. Now earlier, there was so much to talk about. I did not look at the forecast for the cap, so I actually didn't even pay any attention to Tuesday. And honestly, potentially the reason for that is because it's Tuesday, right? There's so much that'll change between now and then. But I'm going to go ahead and do that for you now. and then I'm going to sign off. So let's see. Let's go to this Tuesday. Where's Tuesday? All right, not too far. Okay, so here's Tuesday with a lift like so, which tells me there's a little dry line action just on the west side of Canadian County. So let's see what that looks like. Yep, there we go. All right, so we got all the 60-plus degree dews. Ooh, mid to upper 60s. So we finally got some real decent low-level juice here. I already see a problem. See these winds south-southwest? See these winds south? So what does that tell you? This little dry line action between the two, the moisture and the dry air, there's no convergence along it. The airflow is parallel to the boundary, which means you don't break a cap in there if it's significant. If there's no cap at all, then not a problem. But if there is a cap at all, it doesn't break. So let's take a look. So in this particular case, it does not have a cap, and we are Canadian County. Where did I pick? I picked right on the line of Canadian Oklahoma County is what I did. So still in the juice and just a little away from the dry line. Oops, I just closed it. Let's go back there. Okay, so in this particular case, what are we missing here? We got some weakness that's causing some issues in the upper levels. Okay, so we do have only 50 knot winds around 200 to 300 millibars. So the jet aloft is fairly weak. So the evacuation of air is weak, which means storms can't quite get to their max potential that they normally would. And this also causes probably a little cycling of the storms. Let's see here. But the low-level cloud bases look low enough. There is a tiny cap here, but it looks like we should get just warm enough to break it. The helicity values are good, anywhere from 3 to 400. Supercell category is a 25, which is off the chart. Hail, ship model 3.4, it's off the chart. So that's more than 2-inch size hail. So it'd be gigantic hail, baseball hail or larger. All right, let's see what else we got. Bulk shears, 40 so. Supercell, analogs, plenty of them, significant back in time. Significant hail back in time. Look at this hail. They found a hail that correlates to this pattern in Little Rock of 5 inches in diameter. They found one that was 2 3/4, so baseball size hail, here in Norman during a similar setup for an event there. Cape values up around 4,000. That's ridiculous. It's plenty. Wind damage number 2.4. So it is a garden variety mixture of plenty of wind damage. And then finally, if you look at the possible hazard type for a tornado, not only does it have a tornado, but it does have a significantly strong tornado up into the EF4 category. So this, again, is just a model forecast, which will change a few times between now and, of course, the day of. This is the early preliminary data for it, though. So that's kind of how that looks. Let me look down here. Let me tell you what. Let me go look at a couple other things. So that was the dew point. This is the theta E axis, which runs right along this region. So it's influxing in all that moisture. Wind speeds are quite strong at the surface. They are about 23 knots. So that's all conducive for severe weather. All right, let's see what else we got here. Oh, let me go to 500 millibar speed max. So we've got one kicking through the state, mostly anchored right along the dry line area. They're moving overhead. Let's check out that through. Oh yeah. So there's that weakness I talked about in the upper levels, 300 to 200 millibars. We don't have a jet overhead. We have very weak winds aloft. So that's going to usually mean a problem for storm structure to maintain itself. There's going to be a lot of recycling, which anytime a storm spends its energy cycling, you get less time for a tornado. So that's a good sign. Because you have to have the updraft and everything with it. It's got to be like in a vertically tilt fashion. You get things that's more too vertically aligned and it's not tilted off. There's not enough shedding of other things downstream. The processes get mixed up, and then you end up more of it collapsing on itself from too much processes above. So we'll see. That's a weakness though, and an otherwise pretty potent looking setup. Let's see. Let's go to 500 millibar vorticity. It's a subtle deal here. There's no brute forcing. So this really is going to depend on whether or not there's a cap. That's what it's going to depend upon. So right now, it has almost the entire state cap free. And this is rare. You usually don't get a setup where there's no cap. Now, that can also be a problem. If there's no cap, you get far too many scattered shower storms develop everywhere. And that can mess things up. Let's see. The cloud bases, of course, are really high, but then they fall into the lower environment for us. Let's see. Lift indices are off the charts all over this whole area. -10. Let's see. Surface-based CAPE, like we talked about, probably around 4,000, which is plenty. There's 3. Up here's almost 4. Let's see. Oh, lapse rates. Do that one. So lapse rates when they develop initially in this environment 7 to 8, then they go up into 8. So big Ale again we talked about. All right, let's go to bulk shear, right up along that boundary. A little weaker when it goes to Oklahoma or City, but it moves east with time with any storms that develop. Storm relative helicity, of course that's good. All right, so let's see here. Supercell composite. Off the charts, of course, all the way from southwest Oklahoma into Kansas. Significant tornado parameter. Really off the charts once you get into Kansas. I mean, woo, big time. So even though things may look a little gloom and doom here, better ingredients in Kansas. Let's see. Cape and shear looks good. Photographs look good across this whole area. So it looks like a pretty good classic setup on Tuesday for some severe weather. But now the question is the model going to produce any storms? Let's take a look. All right, so there's 0Z. All right, so there's 7 o'clock. There's 8, 9, 10, 8, 9 o'clock, 10 o'clock, nothing's happened. And there's midnight to 1 o'clock, nothing's happened. There's 3 o'clock in the morning, 4 o'clock, nothing's happened. Looks like front coming in, dry. That's it. Wednesday. Okay, so what happens, this is interesting. This is really interesting. Okay, so what do I make of this? I go back to the first thing I noticed with the dry line. These are the surface winds. And can I go, let's do this. All right, these are the surface winds. So the models didn't have much of a cap. All right, so it usually means you can get storms to develop. And there's 2 ways you can go with this. That means that the dry line, which is positioned, remember it's the dividing line, and we'll just do something like this. It's really bad drawing, but get the idea. Yeah, because, hold on. Let's do this right. It's just a really crappy dry line. All right, so what happens is you have a vector of wind going this way and a vector of wind going this way. All right, so that is not a component that goes this way and a component that goes this way. Because remember, you're trying to shove 2 air masses into one another. And if you do, then obviously they can't go down, so they have to go up. And that's the bubble that pushes the air parcels upwards to get them to circulate, to then develop into a cloud, et cetera, to a storm. So we don't have this. We have this. No convergence. Now, typically, if there's any cap at all, you don't get a storm at all. 0, nothing. It's a waste. You can load up the environment with the best ingredients in the world, and without convergence, you've got no trigger, and it's done. Now, there's a flip side of this. For whatever reason, let's see, it won't be on this map here. No, it won't. For whatever reason, though, the atmosphere around here, the model seems to think, I'm just going to click on panel here, that we get warm enough to where the weak cap that was there, we break it. And let me go back 3 hours. Yeah. So really, after 4 or 5 o'clock, according to the model, there's no cap at all. Now, usually in this case, you would just get random thunderstorm development along a theta E axis. Let's go, is there a theta E axis on this? No, of course not. Gotta go back here. Alright, so here's the theta E axis. It's kind of broad, but it runs along the dry line. So a lot of times you can sometimes get little storms that'll bubble up along the theta E axis, and then they'll get moved in the environmental flow as to which direction they're going to go. So that we find out, we go back down to here to, they have this? Oh, they don't have that here. Oh, well, that's lame. I thought they did. We'll do this one, bulk shear. So in this particular case, the vector should be to a kind of an east direction, especially being supercellular type storms. They may go north a little bit until they get firmly anchored, but that's kind of how that should play out. And if I click on this, let's see. Yeah, 236 degrees. So yeah, so almost from it's kind of like this little arrow here, just barely, just not quite due west to east. It's kind of a slightly southwest to northeast, but mostly west to east. All right, that'd be the movement from anything that developed along this axis. So the model in this particular case, this isn't the greatest model to try to produce convective initiation, but it's a setup model. In other words, it tells me that some of the ingredients and parameters are there. So if we didn't have the model produce precipitation, we have to go on what we learn in meteorology, just on the ingredients given, what we do. Given the ingredients, what we do, I'd have to call for some thunderstorms that develop on the theta axis and then move east, and be pretty decent, as far as severe weather goes. So we'll see what the model data does, and we'll see what the cap does. Right now, the models seem to think the cap's not a big player, but we're also Saturday night, and this is a Tuesday evening event. That's a long ways away, and that's a lot of error between now and then. So anyway, just want to look at that. Let me see if this guy's come in yet. I don't know what time he does. No, he's late. And then let me see if this guy came in. Nope. Be nice if things come in on time. Alright. So, anyway, for these folks that hung around, we took a little sneak peek at Tuesday. So, this is what you would do. You're gonna hear, you may not hear much about tomorrow. You may hear some, not much. It's a sneaker. It's a sneak event. It's a comes in under the radar, nobody really pays much attention. All of a sudden, whoa, there's a storm that happened, and it had a tornado with it. A little shock and all there, because everybody's focused on Monday, Tuesday, Wednesday. So sometimes that happens the day before the day, we call it. It's the big event the day before the day. It's the one that sneaks in that nobody's paying attention to, and sometimes that happens in these type of setups. It's eerie. Now we'll see about tomorrow. It's a low probability, but a high impact if it does. Okay, so that's that. But on Tuesday, since now Monday's a nothing burger, right? So now you're going to hear all the hype focused on Tuesday, and you're going to hear so much hype. Well, actually, I just showed you the ingredients. And these guys are going to be fear, gloom, and doom. Watch out. Looks terrible, blah, blah, blah. And I have to caution you that today's Saturday, tomorrow's Sunday. That's what I'm going to say to you. On Monday, all right, fine, Monday. If it still looks exactly like it does tonight, fine, go nuts. Because now we're within, that 24-hour to 36-hour window getting Monday morning data in. And so the models will be about as good as they're going to be as far as predicting this kind of stuff. And then the minor details you still only find out the day of, so Tuesday itself. And sometimes the cap strength you don't find out until the day of, because the Weather Service will do balloon soundings and sometimes do extra balloon soundings. So they will be doing a balloon sounding given this environment Tuesday at lunchtime. which they normally don't do, but they will be doing that to see if the models are doing well at handling the cap strength. So, and then from there, they will adjust their forecast. So if it looks like the models are underestimating the cap and we still don't have any convergence along that dry line, you know what happens? Nothing. Now, if the models are doing a good job and they've got the built in on the right profile of temperatures and it shows no cap at all, well, then it looks like we'll have an active Tuesday late afternoon and evening across central and eastern Oklahoma. So that's kind of how that goes, and so some of those details you don't work out until the day of, and that's just because we still need real-time data. Models can only take us so far. We have a lot newer high-resolution model data that we can really get into. That's getting better and better. And since I've been in meteorology since the mid-90s, it's come a long way, trust me. Back when I first started, you don't even want to know what we had to work with. It was so sad. But nowadays, my goodness, these researchers are just cranking these awesome things out, and they're doing a lot better. Makes my job somewhat easier, but then also, you know, you almost have too many, and then you're like, oh, crap. 2 of them say yes, 2 say no. 1 says, what are you even talking about? So what am I supposed to do with that? So you do find yourself in those situations sometimes. So every now and then you got to go back to your old school methods and figure it out. But yeah, it's a good time to be a meteorologist, though, as far as forecasting severe weather or weather in general. And then nowcasting. Nowcasting is when you're in the 1 hour time frame of action. So from now to the next hour from now. So that's not nowcasting. And from there, that's when we track the tornadoes in real time. We give you the track, exactly where they're going to go, the towns they'll hit, cities they'll hit, the highways and streets they'll go over, time of arrival, all that. So we used to not be able to do that 20 years ago. And now it's nothing. It's like we do it in our sleep. It's crazy. So it's good because in the old days, you used to have to alert a lot of people with ancient technology to take shelter when in reality, it was just a street that needed to take shelter. And so think about all the advancements that it took to make that happen. I mean, that's crazy. So that's kind of where we are in today's society. Now, not all meteorologists take advantage of that. So when you do move to other parts of the country, or you've come here from other parts of the country and you watch their severe weather coverage, sometimes it's really bad. It is just like there'll be a guy that stands over a really big map, has a picture of a storm on there, and just reads like this and says, yeah, there's a storm and it's going over this area and all these 12 cities are in the path. And I'm like, and that's it. And you're like, that's all you got for me? You're not going to zoom in? You're not going to show me velocity data? You're not going to show me where the hail is? You're not going to show me where this is, where that is? And on top of all that, you're not going to put up the street where the tornado is currently located. You're not going to put the street next to it where it's going. And you're not going to put the intersection after that. So I just got to look at a picture of a state. You do have that out there. Matter of fact, most places you're going to have that out there. And that's even if you get the cut in to begin with on TV for your storm. So anyway, that's how that works. All right, I think I've said quite a bit. I noticed I froze up a few times. Hey, but I don't think the noise has happened. I think I killed the little static noise that was coming in off and on, hopefully. Jody will tell me after the fact if it's back. But I think I got rid of that, but then I introduced a freeze. Like that one just there. Oh my gosh, I'm dying. Do what? Good. She said the static is gone. All right, well, that's it. I gotta get out of here. This turned into a hour and a half, almost an hour and 15-minute live. That's a long night, man. Okay, you guys be good. We'll talk again around noontime tomorrow. We'll see how it goes. Enjoy the rest of your evening. Have a good sleep, and we'll see you for your Sunday. Take care, everybody. Thanks. Bye.